Please open up your textbooks to page 12. Today's lesson is 1.2, and our purpose is to identify and compute math problems with exponents. Now you'll notice on this page there are several words that are highlighted with yellow. Anytime you see that in our textbook, it indicates that it is a vocabulary word. It is an important term that you remember. In addition to being highlighted in yellow, you'll also see a box on those pages, like this one right here, and it does talk about key vocabulary. So in this case, 3 of our key vocabulary terms in this lesson are on this page, and we're also going to be talking about perfect squares on page 13. All right, let's take a look then at today's lesson. It says a power is a product of repeated factors. The base of the power is the repeated factor. The exponent of the power indicates the number of times the base is used as a factor. Now below this, they have a diagram explaining what each of these vocabulary terms mean. Let's take a look at the 3. We have 3 to the 4th power. The 3, or the blue 3, tells us what the base is. That is the number that is going to be repeated. The exponent, it is in red. The exponent tells us how many times that we are going to repeat the base. So for example, 3 to the 4th power means 3 times 3 times 3 times 3. So when I multiply that out, 3 times 3 would be 9. 9 times 3 is 27. 27 times 3 is 81. So 3 to the 4th power is 81. Let's take a look at some real common powers. For example, down at the bottom in our table, they have 3 to the 2nd power, 3 to the 3rd power, and 3 to the 4th power. When you see 3 to the 2nd power, oftentimes they'll just say squared. If a number is squared, it means that the power is always going to be to the 2nd power. If it is to the 3rd power, they'll use the vocabulary term cubed. Cubed is the same as 3 to the 3rd power. Now once you get beyond the power of 3, you're not going to have shortcuts like that. It's not going to be squared or cubed, anything like that. It's just going to be 3 to the 4th power, 3 to the 5th power, 3 to the 10th power, and so forth. Okay, let's take a look at example 1. This is on page 12. It says write each product as a power. So we have 4 times 4 times 4 times 4 times 4. We know that the base number is going to be 4 because that's what's getting multiplied. Now 4 is getting multiplied 5 times. If you look here, we have 5 4s. So the exponent is 5. If I were to shorten this up, I would write 4 times 4 times 4 times 4 times 4 is equal to 4 to the 5th power. Let's take a look at example B. It says 12 times 12 times 12. 12 is the number getting multiplied, so it is the base number. And it's getting multiplied 3 times, so the exponent is going to be 3. So 12 times 12 times 12 is equal to 12 to the 3rd power. Okay, you're going to see a few on your own problems. It says write the product as a power. You don't actually have to solve these problems. It's just asking you, if you were to write it with an exponent, what would your answer be? Please pause the video and in your notes, write your answer to problem 1 and 2. Okay, when we take a look at problem 1, we can tell that 6 is the number getting multiplied, so it is our base number. And it is getting multiplied 6 times. So the answer to this problem is actually, I'm going to grab my mouse here, or my pencil. It is going to be 6 to the 6th power. 6 is the number getting multiplied, and it's getting multiplied 6 times. Let's take a look at problem 2. 15 is the number getting multiplied, so I know that it will be the base. So I'll just, with my mouse, sorry, it's kind of hard to write with the mouse, but my base number is 15. When I look here, there are 4 15s, so it is going to be 15 to the 4th power. Okay, let's take a look at example 2. It says finding values of power. Now what this means is we're actually going to solve it and find what the answer is. They've already written it as an exponent. So for problem A, I have 7 to the 2nd power. That means that it is going to be 7 times 7, and 7 times 7 is 49. If I take a look at example B, I've got 5 to the 3rd power, so I'm going to do 5 times 5 times 5. When I multiply those 3 numbers together, I'm going to get 125 as my answer. Okay, let's take a look at one more example for perfect squares. Perfect square is when I multiply a whole number by the exponent of 2. So we need to determine if each of these is a perfect square. 64, well, what times what gives me 64? Is there a number that I can multiply by itself to get 64? The answer is yes. 8 times 8 is 64, so 64 is an example of a perfect square number. Let's take a look at 20. There is no way for me to multiply 20 something by something to get 20. No whole number squared equals 20, so 20 is not a perfect square. If I did 4 times 4, I would get 16, and 5 times 5 is 25. So there's no whole number that I can multiply by itself and get 20. Okay, now let's take a look at the on your own problems. You are going to complete these problems in your notes. The first section is find the value of the power, so please write these problems 3, 4, 5, and 6 in your notes and solve them. And then the second part is determine whether these numbers are perfect squares. So write these problems down and the answers to them.